right, guys, now that we've had this opportunity to work on graphing from evaluating a function, which is old school method, and graphing from standard form with finding all those pieces, we're going to now today do vertex and factored form. Remember, vertex form is going to be that f of x equals the x minus h squared plus k, and you might have that a out front on. So this is going to be a take back to unit 4, where we look at how the graph moves. We see here that we have a minus 4. That tells me I'm going to move opposite. I'm going to move right 4 instead of left 4. And this tells me that I'm going to move up 2. So we take that parent function that is here, and we move that right 4 and up 2. So we go right 1, 2, 3, 4, up 2, and then that means I go out 1, up 1, out 1, up 1, out 1, up 3 from there, out 1, up 3 from there. And we have our 5 points, and we graph like that. You can use the table if you wish and fill it in and say, okay, in that case then this goes where x goes right 4. So remember, this would be 4, 1, 0, 1, 4, and we would go right 4 with all our x values, so this would be 2, 3, 4, 5, 6, and then these will go up 2, so 6, 3, 2, 3, 6. Domain, as always, is negative infinity to positive infinity, and your range, it bottoms out at that positive 2, which means my range goes from square bracket to infinity.
But couldn't you put it into standard form and graph it from standard form?
Absolutely. Actually, that was my next piece. We can also convert it to standard form and find all those important pieces. When we do that, that means we're going to take that x minus 4 and we're going to expand it. So that's really x minus 4 times x minus 4, and then we have this plus 2 on the outside. So we will FOIL this, get x squared minus 4x, so minus 8x, plus 16 plus 2. That means you'll have x squared minus 8x plus 18. So then we would have to go through with this. We'd have to do quadratic formula or completing the square to get the zeros, but as you can see, our particular one doesn't have zeros because it's above. So we would have to get the y-intercept of positive 18, opposite of b over 2a, so we'd have to take 8 over 2, which would be 4, and then plug that in to get 2, so 4, 2. And the problem we run into is we don't get those 5 critical points because we don't have any x-intercepts since the graph is above the x-axis. So that's the only drawback. I encourage you to get used to doing it in terms of how it moves. But if you insist upon putting it into standard form, absolutely you will have to be able to put it into standard form anyways for your quiz and your test. Second type of problem we got, factored form. So the first thing we're going to do with factored form, since it's factored, is we're going to find our x-intercepts using the zero product property. That means we've got x minus 4 equal to 0 and x minus 1 equal to 0. So we add 1, we add 4, and we get x-intercepts of 4, 0, and 1, 0, so we can plot those. I'm going to use each tick mark today for 1, just because you'll see why when we get there. Then, step 2 is going to be to convert the function to standard form by distributive property. So we FOIL it out, we get x squared minus x minus 4x, so minus 5x. Negative 4 times negative 1 is positive 4. And once we've done that, our c is our y-intercept, so our y-intercept is 0, 4. So we go up to 1, 2, 3, 4. Right, I'm using the tick marks today. And then opposite of b over 2a to find axis of symmetry in the vertex. So opposite of b, so that'll be 5 over 2, which is 2.5. So that means my axis of symmetry is at 2.5, which is right here. That's why I use the tick marks as 1. And then it gets a little messier. So then we have to put in that 2.5. So we have 2.5 squared minus 5 times 2.5 plus 4. So when we square 2.5, we get 6.25 minus 2.5 times 5 would be 12.5 plus 4. 6.25 minus 12.5 is negative 6.25. Plus 4 would be negative 2.25, which means that my vertex is 2.5, negative 2.25. So when we plot that, you go over 2.5, you go down 2.25, which would be halfway between. And then the other piece would be to mirror that y-intercept. So we are 1, 2, 3, 4, 5 boxes away. So we go out 5 boxes the other way. And all it does by moving that, counting those tick marks, is it spreads your graph out a little bit. And then we look domain and range. Domain obviously is going to be negative infinity to positive infinity. Range, it bottoms out at negative 2.25, so it goes from negative 2.25 to infinity. And there you have it. That's all there is to it. So what you're going to do now is give these two try problems a shot. You need to graph x plus 2 quantity squared minus 3 and x plus 3 times x plus 1. Identify those critical pieces, x and y intercepts for the factored form, and write the function in standard form. Also graph it and identify the vertex, domain, and range. And then for C in vertex form, identify that vertex and graph the function as well as domain and range. And as always, bring your questions with you to class.